Hello dear students, in this video I'll continue with the assertion reason based MCQs. In this video we will see some assertion reason based MCQs on chapter 4 probability distributions. So here we have the codes for the following questions. Two statements are given, one labeled assertion A and the other labeled reason R. Select the correct answer to these questions from the codes 1, 2, 3 and 4 as given below. So we have to use the first code when both A and R are true and R is the correct explanation of the assertion. Then we have to use the second code when both A and R are true but R is not the correct explanation of the assertion. We use code 3 if A is true but R is false, and the next code 4 when A is false but R is true. So we'll start doing the questions. Most of these questions I have taken from Oswald's sample paper and Oswald's question bank. The first question, a random variable x has the following distribution. So here we have the random variable x which takes values from 0, 1, 2, 3, 4, 5 and 6. And next we have the associated probability given by c, 2c, 2c, 3c, c square, 2c square, then 7c square plus c. So here when x is 0, the associated probability is c. When x is 1, the probability is 2c and so on. Now we have the assertion. Value of c is 1 by 10. Reason R is using formula summation pi equal to 1, we get value of c. So here we can see that the reason is true. If we want to find the value of c, we have to use the condition that the sum of all these probabilities, it is equal to 1. So now let us check whether the assertion is true or not. That is whether the value of c is equal to 1 by 10 or not. So summation pi equal to 1. From this we get c plus 2c plus 2c plus 3c. That is the sum of all these probabilities. It should add up to 1. Plus c square plus 2c square plus 7c square plus c equal to 1. So from this we get 10c square plus 9c equal to 1, or 10c square, let us write it as 10c square plus 9c minus 1 equal to 0. So here this 9c we can write it as, this is a quadratic equation in C. We can solve this equation and find the values of c. So 9c is 10c minus c minus 1 equal to 0, or from this we have 10c into c plus 1 minus 1 into c plus 1 equal to 0. So 10c minus 1 into c plus 1 equal to 0. From this we get c equal to 1 by 10 or c equal to minus 1. So we cannot have c equal to minus 1 because here we are having the probabilities as c, 2c. If we have c as minus 1, then here we will have minus 1, minus 2, minus 2 and so on, which is not possible. That is the value of the probability. It cannot be negative. So the value of c is 1 by 10. Therefore, the assertion is true and the reason is also true, and the reason is the correct explanation of the assertion. So the correct option is option A. And now we have an assertion reason question from this year's sample question paper. So it was given in the sample question paper for 2022-23. The assertion is Kuhu and Beena are two equally capable badminton players. Probability that Beena will beat Kuhu in 3 games out of 4 is 25%. So here we are given two equally capable badminton players and we have to check whether the probability that Beena will beat Kuhu in 3 games out of 4, whether it is 25% or not. Reason is the probability of R successes in n trials denoted by probability of x equal to R is given by probability of x equal to R equal to NCR P raised to R Q raised to n minus R, where R equal to 0, 1, 2 up to etc. n, P denotes success and Q denotes failure in each trial. So we are aware of this formula. The probability of R successes, it is given by this formula NCR P raised to R Q raised to n minus R. So here the reason is true. Now we have to check whether the assertion is true or not. So here the number of trials, it is 4. So here n is 4. Then probability of success is the probability that Bina wins. So probability of Bina wins, it is equal to probability of success, it is half. Here they have said Kuhu and Bina are two equally capable badminton players. So probability of Bina wins, probability of Bina loses, everything is equal to half. So here probability of success P equal to half and Q equal to 1 minus P, which is also equal to half. Now we have to find probability that Bina will beat Kuhu in 3 games. So we have to find probability of x is equal to 3. So here we have to put r equal to 3 in this formula. So n is 4. So it is 4c3. Then p is half. Half raised to 3. Then q is also half. Half raised to 4 minus 3, which is 1 into half. So 4c3 is 4 factorial by 3 factorial into 1 factorial into half cube into half, it is 1 by 2 raised to 4. So this 4 factorial we can write it as 3 factorial into 4 upon 3 factorial into 1 by 2 raised to 4. So this is 4 by 16 or it is 1 by 4. So probability of x is equal to 3, it is 1 by 4, which is 0.25 or it is equal to 25%. So here the assertion is also true. So here both A and R are true and R is the correct explanation of the assertion. So the correct option is option A. Now let us continue with the questions from Oswald's question bank. Next we have the next question. Assertion is variance of a constant A is A square. Reason are variance of a constant A is 0. So here if we think logically, the variance of a constant term is not going to vary at all. So it is 0. Anyway, let us use the formula and check. Now we know variance of x, it is given by expectation of x square minus expectation of x the whole square. So variance of A, it is expected value of A square minus expected value of A the whole square. So expectation of A square is nothing but it is A square. And expectation of A the whole square, expectation of A is A the whole square is A square. So this is 0. So here the variance of a constant A is 0. Whereas the assertion variance of constant A is A square. This is wrong. So here the assertion is false but the reason is true. So the correct option is option D. The next question. The mean of numbers obtained on throwing a die having written 1 on 3 faces, 2 on 2 faces and 5 on 1 face is 2. Reason. Mean is also called average or expected value or expectation and denoted by expectation of x. So here we can see that we have to check whether the assertion is true. Here we can see that the reason is true. Mean is also called average or expected value or expectation and it is denoted by expectation of x. But this reason, it is not a correct explanation of the assertion. Now let us check whether the assertion is true or not. So here we have the event as throwing a die with numbers 1 written on 3 faces, 2 written on 2 faces and 5 on 1 face. So the sample space is given by 1 is written on 3 faces, 2 is written on 2 faces and 5 is written on 1 face. If we consider x as the random variable, that is the number we get in a single throw of a die, then the various values which x can take are 1, 2 and 5. Now probability of getting 1 It is number of favorable outcomes divided by total number of outcomes. So here number of favorable outcomes is 3 and total number of outcomes is 6. Then probability of x is equal to 2. It is number of favorable outcomes. So it is 2 divided by total number of outcomes 6. Then probability of x is equal to 3. X is equal to 5. It is number of favorable outcome which is 1 divided by total number of outcomes 6. So here the mean of the numbers which is obtained, it is given by expectation of x. So it is summation xi pi. So it is nothing but 1 into 3 by 6. So when x is 1, the probability is 3 by 6. Then plus 2 into 2 by 6. When x is 2, the probability is 2 by 6. Then plus 5 into 1 by 6. Plus 5 into 1 by 6. Here the LCM is 6. Numerator we have 3 plus 4 plus 5. This is 12 by 6, which is 2. So here the assertion is also true. So here the assertion is true, reason is true, but reason R, it is not the correct explanation of the assertion. So the correct option is option B. Next we have the next question. Assertion is in a binomial distribution, if P, Q and N are probability of success, failure and number of trials respectively, then variance is given by NPQ. So we are aware that in a binomial distribution, the variance of a binomial distribution is given by NPQ. So the assertion is true. Next we have the reason. For a discrete probability function, the variance is given by variance of x is equal to summation x equal to 0 to n x square into probability of x minus mu square, where mu is the mean. Substitute p of x as ncx, p raised to x, q raised to n minus x in the above equation and put mu equal to np to obtain variance equal to npq. So here we can see that the reason is also true. So if we want to find the variance, so here variance of x, it is given by expectation of x square minus expectation of x the whole square. Expectation of x square, it is summation x square into probability of x minus expectation of x is mu. So mu the whole square is mu square. Now this summation x square into probability of x, it is given by n into n minus 1 into p square plus np, and we know the mean of the binomial distribution is given by np the whole square. So this is n square p square minus np square plus np minus n square p square. So these two will go. Here we will have np is common, we can take it outside. So it is np into 1 minus p, so it is np. Now we know if q is the probability of, if p is the probability of success, then 1 minus p, it is equal to q, which is the probability of failure. So this is equal to npq. So the reason is also true, and here we can see that both A and R are true, and R is the correct explanation of the assertion. So the correct option is option A. Moving on, assertion if P, Q and N are probability of success, failure and number of trials respectively in a binomial distribution, then its standard deviation is root of NPQ. Reason, in a binomial distribution, the mean and variance are equal. So here we can see that the assertion is true. If P, Q and N are the probability of success, failure and number of trials in a binomial distribution, then the standard deviation is given by root of NPQ. The assertion is true. The reason is false. Only in a Poisson distribution, the mean and variances are equal. In a binomial distribution, the mean and variance, they are not equal. They are different. So here we can see that A is true but R is false. So the correct option is option C. Moving on, next question. Poisson distribution is applied for discrete random variable. So this is true. Poisson distribution, it is applied for a discrete random variable. Reason, in a Poisson distribution, the mean and variance are equal. So here in a Poisson distribution, the mean and variance are of course equal. So the reason is also true. But here the reason is not a correct explanation of the assertion. So here both A and R are true, but R is not the correct explanation of the assertion. So the correct option is option B. Moving on to the next question. Assertion is, in a Poisson distribution, if m equal to e, then p of x is given by p of x equal to e raised to m minus x by x factorial. Reason, in a Poisson distribution, if mean m equal to e, then property of x is given by property of x equal to e raised to x minus m by x factorial. So here we can see that only one of the assertion or reason is true. We will check which one is true. So we know that probability of x is equal to k, it is given by e raised to minus lambda, lambda raised to k by k factorial. Here they are using the notation m. So here probability of x, it is equal to e raised to minus m raised to x by x factorial. So when m equal to e, probability of x is equal to e raised to minus m into e raised to x upon x factorial. So it is e raised to x minus m by x factorial. So here the reason is true. Probability of x is given by e raised to x minus m by x factorial, whereas the assertion is false. So here A is false but R is true. So the correct option is option D. Next question. The range of normal distribution is minus infinity to infinity. So here the assertion is true. If you remember the graph of the normal distribution, the bell-shaped curve, it ranges from minus infinity to infinity. So the range of normal distribution is minus infinity to infinity. So the assertion is true. Next we have the reason. In normal distribution, mean equal to mode equal to median. So this is also true. This is another feature of a normal distribution where if a random variable x follows normal distribution, then the mean, median, mode all are equal. So the reason is also true. But the reason is not a correct explanation of the assertion. So here both A and R are true, but R is not the correct explanation of the assertion. So the correct option is option B. Next question. For a standard normal variate, the value of mean is 0. So here for a standard normal variate, the value of mean, it is 0. So assertion is true. Reason, for a normal variate, if its mean is 0 and standard deviation is 1, then it is called a standard normal variate. So this is the definition for standard normal variate. That is, only when the mean is 0 and standard deviation is 1 for a normal variate, we call it a standard normal variate. So here we can see that both A and R are true, and R is the correct explanation of the assertion. So the correct option is option A. Next question. The area under a standard normal curve is 1. This is assertion. So the area under a standard normal curve, it is equal to 1. Next we have a reason. Area under standard normal curve is 2. So here the reason is false. So A is true but R is false. So the correct option is option C. Next question. The standard normal curve is symmetric about the value of mean equal to 0. So here the standard normal curve, it is symmetric about mean equal to 0. So here if we consider a standard normal curve, it is symmetric about mean equal to 0. So here mu is 0. Assertion is true. Then we have the reason. For a standard normal variate, the value of standard deviation is 1. So here the value of standard deviation is 1 for a standard normal variate. Here both assertion and reason are true, but R is not the correct explanation of the assertion. So the correct option is option B. Next question. The mean of x if x is a Poisson variate satisfying the condition P of 4 equal to P of 5 is lambda equal to 5. So here they have said in the assertion the mean of x where x is a Poisson variate and it satisfies the condition P of 4 equal to P of 5 is lambda equal to 5. The reason is mean of x if x is a Poisson variate satisfying the condition P of 4 equal to P of 5 is lambda equal to 4. So we have to check which one is true, whether the assertion or the reason, whether lambda is 5 or 4 given P of 4 equal to P of 5 where x is a Poisson variate. So here x follows Poisson distribution with lambda as the parameter. So in this case probability of x is equal to k. It is given by e raised to minus lambda, lambda raised to k by k factorial. Now it is given P of 4 equal to P of 5. So from this we get e raised to minus lambda, lambda raised to 4 by 4 factorial equal to e raised to minus lambda, lambda raised to 5 by 5 factorial. So e raised to lambda, lambda will go. From this we get 5 factorial by 4 factorial equal to lambda raised to 5 by lambda raised to 4. So this is 5 factorial, we can write it as 4 factorial into 5 divided by 4 factorial. This is equal to lambda. So from this we get lambda equal to 5. So here the assertion is true and the reason is false. So here A is true but R is false. So the correct option is option C. Next question. For a binomial distribution B with parameters n and p, mean is greater than variance. Reason, probability is less than or equal to 1. So here for a binomial distribution with parameters n and p, so if n is the number of trials, p is the probability of success, q is the probability of failure which is given by 1 minus p. So mean is equal to np in a binomial distribution and variance is equal to npq. Here we can see that q is less than 1. Since q is probability of failure, q is less than or equal to 1. As a result, we have np greater than npq. So here we can see that q is less than 1. Since q is probability of failure, we have np greater than npq. The reason is the probability is less than or equal to 1. So the reason for this is q is less than 1. So here we can see that both A and R are true and R is the correct explanation of the assertion. So the correct option is option A. Next question. A random variable x can take values 0, 1 and 2 and probability of x equal to 0 equal to probability of x equal to 1 equal to p. Also expectation of x equal to expectation of x square. Then the value of p is half. Reason, expectation of x is equal to summation x into probability of x. So here we can see that the reason is true. Let us check whether the assertion is true or not. So here we have a random variable x which can take values 0, 1 and 2 and then the associated probabilities, probability of xi, it is given by when x equal to 0 probability of x is p, then when x equal to 1 it is again p, then for x is equal to 2 we do not know. We know that summation probability of xi equal to 1. So from this we get p plus probability of x is equal to 2 equal to 1. So from this we get probability of x is equal to 2 as 1 minus 2p. So this is 1 minus 2p. And here they have given expectation of x is equal to expectation of x square. Expectation of x is equal to expectation of x square. So from this we have summation x into probability of x equal to summation x square into probability of x. So this is because of this reason. Expectation of x is summation x into probability of x. Similarly, expectation of x square equal to summation x square into probability of x. So here the left hand side we have 0 into p plus 1 into p plus 2 into 1 minus 2p equal to 0 square into p plus 1 square into p plus 2 square into 1 minus 2p. So this is 0. Here also 1p it will get cancelled. From this we get 2 minus 4p equal to 4 minus 8p. Or we get 4p equal to 2 or p equal to half. So here the assertion is also true. So both A and R are true, and R is the correct explanation of the assertion. So the correct option is option A. So these are some of the questions on assertion reason from chapter 4 probability distributions. I hope this video was useful for you. If you have not subscribed to my channel, please subscribe. If you like this video, share it with your friends. Thank you for watching.